Good morning, friends. The word nano is a very enigmatic word. Everybody has heard about nano, but they don't know what it is. Does it mean that nano means new science? What are the applications of nano? How will this help humankind? This question has made the world of science, very, very important. Nanoscience is nothing but the behavior of electrons when they are confined in a very small region, which is approximately of the order of the wavelength. What happens is, when you confine the electrons into very small regions, they behave differently. So I can actually, in other words, I can control the property of the of the material by changing the size. And this important thing reminds us of several important people. For example, Richard Feynman, Harry Kroto, our own Professor C.N.R. Rao, Ijima, who have contributed to this field enormously. This field has allowed people to think beyond their boxes, because it involves the particle in a box, which requires the language of quantum mechanics to understand the nano properties. Now, I said that the property can change when the particles become small. That means I can tune the properties, I can make a material of the properties I want. Not only that, by controlling the shape and the size of the material, I can get different properties of different materials in one material. Isn't it wonderful? That should enable me to tailor-make properties. These effects affect not only the structural properties, they change the electronic properties, they change the magnetic properties, the thermal properties, and all sorts of optical properties of these materials, and that makes it very exciting. The nanomaterials right now in the optical range, means in the colors that we can see, have become very interesting. But what is important is there are also enormous applications both in the ultraviolet region and the infrared region. There's a lot of research going on in this field to not only synthesize nanomaterials or not only understand properties, but to apply nanomaterials. The challenge has been, how do I make a bulk material which is usable, but it still has the nano properties? And so that means it is not only making nano properties, but also making them very, very repeatable, very, very self-assembled, and very, very cohesive. And that challenge is there. This field is amazingly integrated many fields of research. It has integrated the physicists, the chemists, and even the biologists. By looking at this, now people think that they come out with a multidisciplinary approach to look at, understand, and to solve problems. The major issues and the problems which nanoscience is already addressing is issues related to energy. We know that we need to produce energy. Is it possible to convert sunlight into hydrogen, to split water to make hydrogen? For example, what is called as artificial photosynthesis. Is it possible to clean water so that we can provide very good clean drinking water to the masses? Is it possible to clean the environment as we pollute it while the development goes on? Is it possible that we use in healthcare? Is it possible to do early detection of diseases and to do drug deliveries without any side effects? So all these issues have challenged the science of nanoscience. So people all over the world are interested in working in solving these problems. The potential is very large, but still there is a long way to go. Again, as I said, the challenge is to get reproducibility, is to get precise properties, and also to get the assembly which is required to make the bulk materials. So in fact, in one sense, that many applications in nanophotonics, optoelectronics, catalysis, and drug delivery, and disease detection and treatment are some of the fields where enormous effort is being put. Now, for this, the research looks very simple, but eventually to ultimately take this science into a product is a long challenge for all of us. And it's very important, though the potential of these materials are enormous, limitless, and only the imagination is the limit, but actually bringing it in action is and will continue to be a challenge. But eventually, nanoscience and nanotechnology can affect every aspect of life, of human life. It can change the way we live for the better. But of course, there are also possibilities of other bad effects, deleterious effects from nanoscience, which we are not aware at this time. Some small research is going on also in this direction, but the positives seem to be much more overweighing compared to the negatives. So in the sense that we need a lot more research. We know that nanoscience has been talked about for the last maybe 20-25 years, but there is not enough products in the market. It's not made any big changes to human life, but the potential is there. This is a research-based problem. It is a technology-based problem. It is an engineering-based problem. So we need a proper coordination of science, technology, and engineering to eventually make what the potential is able to offer. So this is a long grinding process, but we are definitely on a positive slope. And I'm sure with more research, more interest, and more funding, it may become a reality very soon. We attract a lot of good students. We wish to attract a lot of good students to this field of nanoscience and nanotechnology, so that the dreams or the potential are realized as soon as possible. Unfortunately, most of the bright students get into other aspects of engineering and technology and mechanics, but we think that it's very important for the brightest of the students to come and work in this field of nanoscience and nanotechnology, so that eventually it is, of course, scientifically very interesting, very curious to find out what happens to particles in small sizes, but not only that, to also be able to produce products that can change the way of life, that can change the way we live in this world for the better. Thank you.